Are you a developer looking to unleash your artistic side but don't know where to start with AI art? The good news is you can now harness the power of Stable Diffusion directly within Python. This video I'm going to show you how it works, how I made it, and what you can use something like this for. Okay, so imagine you type in an astronaut riding a horse on Mars, and boom, Python just spits out an image like this. That's the magic of Stable Diffusion. So what exactly is Stable Diffusion? At a high level, it is a type of generative AI model that specializes in turning text into images. But under the hood, it is doing something pretty clever. Unlike older models that directly printed pixels, Stable Diffusion works in a compressed, hidden space called the latent space. Think of the latent space like a doodle pad that the AI uses, where it sketches through rough ideas before finalizing them into high quality images. By working in this compressed space, it is way more efficient. You can run it on decent consumer GPU rather than needing a supercomputer. The stable part comes from the training process. It was trained on billions of image caption pairs, so it learned patterns on how words relate to visuals. That's why when you say a cat wearing sunglasses, it doesn't just randomly guess. It has seen enough cats and sunglasses in its training data to blend them realistically. Here's the step by step on how Stable Diffusion actually makes an image. Text encoding. Your prompt, let's say an astronaut riding a horse on Mars, first goes through a language model like Clip's text encoder that turns your words into a bunch of numbers called embeddings. These embeddings capture meanings of your sentence. Next is the noise party. Instead of starting with a blank canvas, the model begins with pure noise. Imagine static on an old TV. Step 3. The diffusion process. The model has been trained to denoise images step by step. Guided by your test embeddings, it repeatedly cleans the noise. Each step makes the image slightly less chaotic and more structured. The latent space trick. That's step 4. All this happens in the latent space, compressed image representation, not the pixel space. It's like sculpting clay model before painting it. Faster and most resource friendly. Denoising the final image. Once the noise has been refined enough, the model decodes that latent representation back into pixels you can actually see, and boom, you just got an astronaut horse picture. This whole process only takes a few minutes or even seconds on a good GPU, which is honestly insane considering how complex the math behind the scenes is. This is why GPUs are so advanced to this day.
Okay, so this is the code. So first off, I'm importing the main library, so Torch and Diffusers. From Diffusers, I'm importing the Stable Diffusion pipeline, the transformer, and the bits and bytes configuration. And then this is the bits and bytes configuration. This is where I tell the model chill out, and then basically use just Torch bfloat 16, which keeps the memory less, but still keeps us almost the same quality. So, and then this is the model Stable Diffusion transformer. And then this is the pipeline where basically it loads the model with the transformer, which is over here, and then with the torch data type as I specified before, the torch b float 16. And then this is also an important line over here, pipeline enable model CPU offload. So this line basically says that okay, so now if something is running on my GPU and my GPU is extremely capped out and it's running at its full potential, it basically runs it to my CPU, it offloads stuff to my CPU, so like my PC basically doesn't explode, and it allows you to run high intensity models on a lower GPU. And then these are the prompts. So there are 4 prompts over here. So these prompts are basically just strings, comma values. So it's quite easy for you to add your own prompts. And just so you guys know, all this code is in the description below. In case you guys want to like change it or ask me any questions, you can comment down too. I'll answer them. And these are the results, which basically feeds the prompts and the inference steps, guidance scale, and then the max sequence length to the pipeline, basically getting on the images. So the inference step basically that means 40 stroke paintings. Yeah, you can take it that way. So 40 stroke painting. So the higher the number, the more detailed images you're gonna have. And guidance scale, that's pretty simple to understand. Guidance scale is basically how close the AI will be to like your prompt that you have gave it. So if it's lower, it's gonna go like more creative, but if it's a higher number like 8, it'll be closer to the prompt that is given. And the max sequence length, you can leave that at 512, that's fine. And then so the images variable over here basically just takes the result, it just takes the images from the results, and then this is just for saving it, so it iterates to every single one of those images and saves it. And yeah, that's basically all the code.
That's my Stable Diffusion text to image project in Python. I wanted to make it lightweight and honestly fun to mess around with. Next, if you want to try the code or mess around it or see the examples for yourself, I have left the GitHub link to all the project files in the description. This is my first video, so if you liked it, a subscribe would really seriously mean a lot. Thanks for watching, and here's my favorite generation so far.